Is that okay? Okay, I thought I'd start off with this quote from Mark Twain. The work I've done actually originated, and ironic given the events of last night, in counter-terrorism both before and after 9/11, particularly in looking for what was called weak signal detection. So how do you find the things that after a disastrous event you realise were relevant, but you didn't see that they were relevant at the time? And so that concept of weak signal detection is key. And certainly out of that, not only my own work, but other people's work, it's actually where you think you're comfortable that you're most at threat, which is what the Twain quotes talk about. When you feel you've got your users sorted out, you feel you know what the requirement is, you're pretty certain you're going down the right route, that's where the really nasty surprises actually happen. The other problem you've got is that this is dominantly an engineering community, and just to throw some numbers into this, 50% of current jihadi terrorists have engineering degrees, which compares with 3% of the actual engineering degrees within the population. The psychological argument for this is there is a need for certainty, all right, within an engineering culture, and intolerance of uncertainty. Now, I don't want to go too far with that, and I've been slightly mischievous in saying it, but you also need to realize that there are two departments with a high degree of partial autism in all major universities. One is economics and the other is IT. So this actual structuring, certainty, detail, attention has huge power and capability in some areas, but can actually give you major problems when you're dealing with developments in areas where, to be quite honest, the users don't know what they want yet either, and you haven't got any idea what their actual needs are. And I'm going to come at the end to new methods or tools to actually flesh out the unstated and unarticulated requirements, and move away from the idea of a user requirement specification as a starting point of an engineering drawing. And I'm going to argue that Scrum tends to take too many assumptions about what users want at the starting point, and we need to go back a bit. So that's the plan for today. In order to do this, I need to introduce a key code metaphor or two and some concepts. The first metaphor I want to introduce is between using a cookbook and working with a chef. Now, if you ever actually get people to cook a meal for you, go to a house somewhere, and they've got recipe books, and they can produce a reasonably competent meal, provided all the ingredients listed in the recipe book are present, and provided they have all the correct instruments, and the kitchen has all the right tools. The trouble is, if something goes wrong with that, they can't adapt, because they're following a recipe. They don't understand two things, key things actually. This is from Aristotle. They don't understand, they don't have the practical wisdom of a chef. They haven't learned through a 10 or 15-year apprenticeship. And they haven't got the theoretical knowledge of a chef. They don't understand the different tastes and how different tastes combine. So the absence of theoretical knowledge and practical experience means they can't adapt to uncertainty. On the other hand, the chef has that capability. And a big problem we have in management science in general, and in IT and Agile in particular, is a desire to work with recipes, particularly best practice recipes. Give me something, tell me what the outcome is, tell me where you've done it before, and I can repeat it. That's a recipe book culture. What we really need to work is to a chef-based culture. And just to make it clear, putting the recipes online doesn't make any difference, right? They're still recipes, however they're constructed. So I'm going to come back to that several times, but think about the difference between a chef and a recipe book user. One actually can handle high levels of uncertainty and variation, the other can't. Right? But chefs take 10 or 15 years in training. Now, it's not something that you can acquire by going on a 2-day course, filling out a multi-choice questionnaire, and saying you're a master in something. I picked nothing in particular. But fundamentally, the process of mastery is a lot more sophisticated than that. Two key words I'm going to use as well. One is called exaptation. This is actually something the IT community really needs to pay far more attention to. That is actually a picture of a car in Bangkok a couple of years ago during the major floods. And what happened is the floods were coming, somebody quite valued their car, and they happened to have a very large plastic bag in their garage, so they drove the car into the plastic bag and sealed the end, and their car survived the flood. Right? This is actually quite intelligent, and people in New York should really pay attention to this because they missed out on the opportunity. There are now specially designed car bags in all garages in Bangkok, because the idea is now caught on, there will be more floods, you want to protect your car, so now I can actually design something for that purpose. Now that process in biology is called exaptation. It's something designed for one purpose, gets used for something else accidentally, which proves more valuable. Now that's actually a quite important process. You know, the other famous case, 1943, a Raytheon engineer maintaining a radar machine or a magnetron on a radar machine notices that a chocolate bar melts in his pocket, and from that we get microwaves. If you actually look at the history in both biological evolution and technology evolution, the major changes are exaptive, not adaptive. It's not that somebody knew they wanted something and designed it. It's that somebody found out by accident that something could do something they hadn't expected, like hashtags on Twitter. You can think of lots of examples. And all of a sudden, something completely new grows. Now, managing for exaptation means deliberately creating a level of uncertainty and networked interaction which IT communities are traditionally hostile to. And that's partly because of the measurement culture and everything else. So think exaptation, because that's going to be important. And Apple, by the way, are masters of exaptation. If you actually look at Apple's history, they don't invent things. They find things which somebody invented for some other purpose and just redesign them or repurpose them for something else. And that gives them massive incremental change. The other word, and this comes from philosophy, is called coherence. Coherence is kind of like a halfway house between it's empirically true and it's everybody's opinion is equally valid. You know, the idea is some opinions are coherent and some aren't. And as a metaphor for this, it's kind of like, that's a picture of a spider's web early in the morning in England. You know, you can see it was what it was, you can see it's still coherent, but it's only partially formed, it's only partially there. Now, partly it evolved in philosophy to deal with some really stupid idiots called creationists. Yeah, I mean, I like this, love this cartoon, but it's quite a cute little theory, all right? But the idea that all theories are equally valid is actually pretty stupid. Some theories, even though they're not provable, are coherent to the facts, and some theories are incoherent to the facts. Now, this becomes very important when we come on to understanding user requirements at the early stages of major projects, because some ideas will be coherent and some ideas will be incoherent, and therefore determining which are coherent and which are incoherent is important. And the trouble is, in management science these days, it's either kind of like it's empirically true or it's a great leader makes a choice. Yeah, and that sort of dichotomy is actually quite dangerous. We need a much better evidence base for what we're doing. And kind of like just to flavor on something I've said already, the idea that you can just get a user executive to design the requirement and to deliver to that is a manufacturing mentality. And I've argued elsewhere, I'm not going to major on it today, that manufacturing models are entirely inappropriate to software development. Software is a service, it is not a manufacturing process. And service models have to be co-evolutionary, they have to increase interaction. They can't be staged or structured, and therefore we need to rethink the front-end processes on Scrum radically, because we're overemphasizing manufacturing at the cost of service. The reality is users generally don't know what they want until they get it, and then they want something different. Yeah? And the idea that users' opinion should always come first is a pendulum swing away from the equal stupidity of we in IT know best. Yeah, you need something which is much more interactive between the two, and I'll talk about how to do that later. That leads me on to complexity, and normally these are the two alternatives presented. Yeah, it's kind of like either it's chaos or it's complexity. Now, there are various ways of defining this, and there are lots of people who just use the words without even thinking about the definition, but that's for another day as well. I use the constraint-based definition. This comes from Giraro and others, because the definition leads to the way you act. You define systems by the type of constraint. Therefore, by varying the constraint, you can change the type of system you're dealing with. This works quite simply. It's as, you know, if I have a highly constrained system, so the system rules, the system structure, limit agent behavior into highly predictable paths. That's called an ordered system. On the other hand, if the agent's unconstrained, there are no constraints whatsoever in the system, so everybody can do what the hell they want without any rules. That's called chaos. Yeah, sometimes that's in a sense of randomness. Now, both of those systems have value. Right? So an ordered system is predictable, it's best practice, I can ensure repeatability. A chaotic system with completely randomized agents actually allows me to use a whole body of statistical techniques which have value. So for example, wisdom of crowds, if you come across that in the popular literature, Yeah, if that actually assumes a chaos-type environment. So each, let's take the two examples. Farmers guessing the weight of a cow. If all the farmers guess the weight of the cow without knowing what the other farmers' guesses are, then the average of all the guesses is normally the actual weight of the cow. Or the other case where an American submarine grounded off the coast of Portugal, where actually they got groups of experts around the world to estimate the position. None of the estimates were right, but the average of all of the estimates was 6 meters away from the actual submarine. Now that's leading into a body of work we're currently working on called human sensor networks, which is building large networks of respondents who can be asked questions in real time in order to provide an evidence base for conditions of extreme uncertainty. And that relies on chaos. It relies on independent agency without constraint. So don't get these into, you need to think about the words in terms, to some extent, their scientific meaning. So ordered systems, constraints are such that all behavior is predictable. Chaotic systems, agents are completely random, they're separate, they're not connected. Now, one of the problems is if you over-constrain the system, which isn't naturally constrainable, then it breaks and fragments. Now, we did work when I was in IBM, which actually showed the density of informal networks is directly proportional to the level of perceived bureaucracy. So the more bureaucratic the organization, the denser the informal networks, because the more the informal community has to work to make the formal system work despite itself. And of course, the problem with that is the informal system will work for a long time, so it disguises failure in the formal system. So when failure in the formal system comes, it breaks catastrophically. Right? So you've got to be very careful on order because of the danger of this fundamental shift into chaos. Then there's a third type of system in which the system constraints are such that they do constrain agent behavior, but the agents modify the system as they interact with it. And the phrase for that is the system and the agents co-evolve. And that actually makes it inherently unpredictable. You actually, and this is kind of like probably the key phrase to get across, a complex adaptive system isn't causal, it's dispositional. You never get a repeating relationship between cause and effect. The same thing won't happen again the same way twice, except by accident. But I can measure the dispositions. This system may evolve in this direction, it may not evolve in those. And that switch from causality to dispositionality is key in a whole body of strategy. Now let me use a metaphor for this. I'm not going to use the children's party story because you can get that on video. The other one I've been using lately, particularly for IT communities, is to think about a round table. And around the round table there are electromagnets. Some of them I control, and some of them are controlled by people I know. And some of them I've got no idea whether they're controlled or not, but they're changing in polarity and strength. Everybody got the image? Okay. In the middle of the table there are a bunch of iron ball bearings. And for the pedants amongst you, the table has a high coefficient of resistance. All right? This is a metaphor, don't take it too seriously. As long as the magnets don't change in strength and polarity, the pattern of the ball bearings stays stable. If I change one of the electromagnets, I can predict the behavior of the ball bearings. And I will get repeatability. So if I increase it, they'll go like this. If I decrease it, they'll go like that. The trouble is, as I start to change all of the magnets, I can repeat the same action on this magnet. It produces a completely different effect. Not only that, the ball bearings get magnetized as they move through electrical fields. Right? That's a complex adaptive system. And the magnets are what we call modulators. And this is one of the key differences between complexity theory and systems thinking. We talk about modulation, not drivers. A driver implies linear causality, whereas a modulator says it's modulating system effect. Okay? So actually, that's what you're dealing with when you're designing complex software problems. You're dealing with a modulated system where actually small things can produce massive differences. The effect is never quite the same way twice. That thing which worked for those guys you spoke to at a conference actually produces the opposite effect when you try it. And the reason is the context is shifting and the context is different. You need a world where you need chefs, not recipe book users. Right? So a complex adaptive system is co-evolutionary in that nature. And I say that's important to realize, but we manage it in a different way. The only way you can really manage a complex adaptive system is by interacting with it. So actually the approach moves from fail-safe design, trying to design something to cover all contingencies, into multiple parallel safe-to-fail experiments. Because you don't know what experiment is going to work until you see the effect. and probably combinations of the experiments will produce the right result. Now, something I'm going to come back to in about 15 minutes when I want to talk about shifting Scrum from linear repetition, trying to get it right repeatedly, to multiple parallel experimentation. So if you're dealing with high levels of uncertainty, you can't do one thing many times until you get it right. You need to do many contradictory things in parallel to see what you should do in the first place. And that actually is much lower cost and more effective, and it's an earlier stage. Right? So think about that shift from fail-safe design to multiple parallel, contradictory, safe-to-fail experimentation. As I say, we'll come back to that in a minute when I talk about specific methods. And the other key thing to understand is you can't eliminate complexity. You have to absorb it. Anybody who tries to reduce complexity or make it simple is being simplistic. And I'll repeat that because that may be a subtlety in English, and I know I'm speaking in a foreign language, but if you're too simple where you shouldn't be simple, it becomes simplistic, petty, trivial, and you're going to get it wrong. Yeah? Actually recognizing and dealing with high levels of sophistication, high levels of uncertainty, the ability to stand above something and see the patterns and move in slow, careful ways with multiple stimulations, it's much more about navigating or managing a complex ecology than it is about designing a machine. Yeah, and that sort of metaphor difference between ecology and engineering is also critical. Now from that, we get the Cynefin framework. Cynefin is a sense-making framework. There's a difference between a categorization framework and a sense-making framework. In a categorization framework, the framework precedes the data. In a sense-making framework, the data precedes the framework. So if you take a classic 2x2 matrix, again, we did experiments on this when I was in IBM. We took a McKinsey strategy matrix. We created a data set of several hundred items, of which only a third of the items actually fitted the matrix. Then we gave the items in the matrix to managers on 4 continents in industry and in government, and they made everything fit the matrix regardless. You give people a structure with authority, they will make everything fit it. And that's actually where things go badly wrong with categorization errors. Yeah, putting things into little boxes is actually quite dangerous if you're dealing with high levels of uncertainty. Now, I'm not going to go into this now, but Cynefin, when in proper use, the boundaries within the framework emerge from the data in a social process. Now, that's something we teach on courses and the like, but it allows the system to be much more resilient and to be contextualized to the organization itself. Either way, treating it now partly as categorization, Cynefin treats order into 2, simple and complicated. In simple order and in complicated order, there are consistent repeating relationships between cause and effect because the constraints are high. The difference between simple and complicated is in simple order, the nature of the constraints and their value is self-evident to any reasonable person. Therefore, I can effectively, in the model, sense, categorize, respond. I can gather data, I can see what the data is, I can decide which box it fits in, and within that box I've already decided what to do. That's the domain of best practice. And it's the only legitimate domain of best practice. Not only does there have to be repetition, but it has to be self-evident to any reasonable person that there is one right way to do things. In complicated order, on the other hand, there is a repeating relationship, but it's not self-evident to everyone. So I have to go through some analytical process or bring in the right level of expertise in order to determine what the right thing is to do. So I sense, analyze, respond. And that's actually where most systems analysts sit. The assumption is the analysts will go out, they'll interview the users will say what they want. We all know the way that process works. Right? Or we actually conduct proper experimentation, we do survey-based research, there's lots of ways of handling this. Or we bring in people with deep experience or expertise who we trust. But the point in this model is there will always be variations. So we now do good practice, not best practice. That means if you've got the right expertise and training, you can vary the method. And that's actually a very important distinction. Because if you allow people to vary the method who don't have the right expertise and training, they get it badly wrong. But if you don't allow people who are capable to vary it, they won't believe you, you lose credibility, and the shadow community will build. Things will go underwater. Now that's where most people work. We then get the complex world, in which the model is probe, sense, respond. So again, that's the safe to fail experimentation. I understand by interacting with the environment by multiple experiments. And then the chaotic world, where if I fall into it accidentally, as opposed to using it deliberately, I act sense respond. Now, I want to make something clear here. There's a trend in the Agile community at the moment to say, my preferred method is complex and your method is complicated. This means my method is superior, your method is inferior, I'm more progressive than you're more progressive. So you get these huge debates about Scrum is complex, Waterfall is complicated, etc., etc. And we won't get into the Scrum Kanban debate. Other speakers talked about that yesterday. And then the really revolutionary people say, oh, you guys in complexity, you're old hat, we're now into chaos. I'm a chaos manager, I'm a magician, right? Now, this is total fucking crap, all right? Excuse the language, right? The reality is, if you really understand the framework, at different stages, methods are all not about being put in a box, but about moving things between the domains. Scrum, properly understood, is about shifting things from complex to complicated. Because when they're complicated, you can scale and exploit the results. Complex is about exploration. Complicated is about exploitation. So if you hold everything in the complex for too long, nothing gets done. As you start to structure things, design them, you run through several sprints, the users buy in, you're actually shifting the problem from the boundary of complex, complicated, into complicated. So you're dealing with dynamics. It's also important to realize Cynefin has a central domain, so people who draw it as a 2x2 matrix tend to get vilified these days. The central domain is called disorder, which is a state of not knowing which of the domains you're in. And that's actually quite important, because that's where most people are. Most people assume there's one right way to do things. That puts you into disorder. What Cynefin said is there are actually different ways of doing things dependent on the nature of the system. And actually, the thing you do in a complicated domain may be exact opposite of what you do if it was complex. So actually, trying to go down a single approach actually means you're disordered. And that central domain is quite important. And the bottom line is drawn as a catastrophic failure. It's a fold, you fall over the cliff. And that's my point about informal communities, keeping systems alive when they shouldn't be. That's the complacency boundary. It's when you're absolutely sure you're in control and command. That's when you're in the danger of falling over the cliff. Yeah? So it's not drawn, simple is not next to chaos just to make it a 2x2. It's next to chaos because actually simple is a boundary area with chaos, with losing all control. Well, actually, if you go to the UK, there's one surefire indicator of this. The minute an organization builds a grandiose new headquarters, you kind of like know they're about to go under or have a major catastrophe. It's been a sure and certain predictor for several decades now. And that's hubris. It's complacency. It's believing you're in control. That's when you're at high vulnerability of switching over. And that's what's covered in the Harvard article. You can buy a copy or you can search the web on the title of the article. I leave it to your conscience, which you actually do. And that actually describes that framework in the context of leadership, but that's kind of like what we're all about anyway, in various ways. Now, as I say, it's important to understand that fundamentally, Cynefin is about dynamic change, not about static categorization. What you're trying to achieve in a software development environment is a constant cycle between complex and complicated. You really don't want to be down in simple, and you definitely don't want to be in chaos. What you want is constraint relaxation so that new possibilities emerge, shift into complex. Increase constraint as you see what experiments work and don't work, shift into complicated. So if you can manage that constant oscillation between the two top domains, you've got a dynamic learning environment which is resilient, which can cope with uncertainty. Every now and then you'll get ossified, you'll get constrained in your ways. So often when we start with companies, we have to do a bigger switch at first. It's called a shallow dive into chaos. It's relax more constraints than you would normally like to do just to shake the system up so that you get some novel patterns. So that's like a reset picture, but you really want that dynamic movement. Only a small amount of things should go down there. And the things which go down there to die. Now, they may take 15 years dying, and they may have high utility while they're down there, but they've reached the end of their development cycle. These are legacy systems. Yeah? They're things which you're not going to change, which you don't want to maintain. They have utility, but they'll be replaced completely when they come through. Yeah? So the argument is not to try and put things down there and pull them up, but try and keep it, only put things down there which you know are completely stable, you're not going to need to change. The rest of the stuff you need to keep at the top. For those of you into object orientation, this is the argument I was making back in the 80s, is object orientation is actually all about that. And properly understood in object wrapping of legacy systems, this is all about creating an environment which can be dynamically changed rather than an environment which is highly structured. And I'd argue strongly that these days we need to think of we need to stop talking about applications, and we need to talk about, we need to stop talking about designing applications. And we need to start seeing applications as emergent properties of objects within architectures interacting with people. It's the interaction of software objects with people within within resilient architectures that allows novel or new applications to emerge. The idea you would design something like SAP again in a modern technology age is basically fundamentally, I think, mistaken. Anybody implemented SAP? Yeah, anybody tried to pay a small customer in the first 2 years after you implement it? You can't, because all those big application packages assume an averaging process. It's like SharePoint. I once famously tweeted at a conference when I was very angry, SharePoint is to knowledge management what Six Sigma is to innovation. And it was a deeply negative tweet, and it went viral, and I got into some trouble for it, but I stand by it. Right? These days, and if you look at the way social computing works, it's lots of small things which interoperate with other things so that patterns form from the interoperation. Yeah, we actually need to design within architectures. And we also need to realize that architecture is not the final stage of a design, it's a sort of visioning type process at the front. Yeah, I'm blogging about that this week. Those of you who want some more backup on this is a recently published Gartner report. Just came out about 4 or 5 months ago, which actually says, they've started to recognize the Cynefin framework. And particularly in operations, they actually say it's now going to become a dominant framework in terms of understanding where things go. I can't give you copies of that, you know what Gartner charge, but that gives you some third-party endorsement. The other thing that Cynefin allows us to do is what I call fractal frameworks. Fractal means self-similar at different levels. So I can define a framework for strategy, and you now see the way Cynefin is actually defined in practice, although it's a very blurred picture there, for which I apologize. But each of those little hexagons, they are hexagons, represents a use case, or a user case, or a micro-narrative from the organization. So the domains of Cynefin and the boundary spaces are not defined by abstract principles, but by real stories from the organization you're working with. Because we all work on story-based definitions. We're pan-narrans rather than Homo sapiens. Yet we're the storytelling apes. Story is still the most fundamental method of knowledge transfer in human beings. Yet we tell stories because stories carry rich meaning. We don't give people highly structured material. If you want some revolutionary stuff on this, anybody got a corporate value statement? No? Okay, you've escaped that? Well, carry on escaping it. The minute you write your values down, you just lost them. This is 101 anthropology. What it means is every slide set and every business plan from now on will contain those words, regardless of its content. We're actually now using work to replace value statements with parables. Because parables are the way that religions teach values. They don't state the values, they tell stories. And actually stories are a far more effective way of communicating strategic intent or even user intent than any structured process in terms of the way we work. So that's Cynefin defined for strategy. And of course then, you define the model with examples from technology. See my point about fractality? You're using the same framework, but it's defined differently for different communities, but it gives a common language. And of course, within that, you make sure that there are some common items within both structures. This is starting to create a different means of communication. I can now go to IT, from IT to strategy, and say, look, it's complex because it looks like these things that you all agreed were complex. Therefore, we're going to do this. And a large part of this is actually enabling a different type of communication. We agreed that these examples from our past were complex. This looks exactly like them. It doesn't look like those. Therefore, we probe, sense, respond. We don't do analysis. We don't apply best practice. Because the reality is most people argue based on past examples. You actually analyze people's arguments in a controversy. They're all trying to associate their idea with something in the past which worked, and the other person's idea with something in the past which didn't work. Yeah, that's our natural form of argument. So we need to build models based on narrative, because that's the way we evolved to be. That leads me on to the complex space, and we actually need to start to think about this a little differently. Yeah? It's not just about getting people together. Now these are one of a series of what are called domain models within Cynefin, so I'm just going to go through the complex one. These also exist for complicated, chaotic and simple. And they're designed to be entry points into this way of thinking without having to understand complexity. So you can come to them from Cynefin, or you can come to them standalone. The general form of the framework is a 3x3 matrix. The bottom left-hand side is kind of like the transition to a more unordered domain. So in complex, that's chaos. The right-hand transition to a more ordered one, so this case is complicated. Yeah. On the horizontal dimension, this time I've got the type of evidence available. And on the vertical dimension, I've got the degree of consensus or agreement. Now, this is not the same thing as Stacey's matrix for anybody who's seen that, because the idea is you can validate empirically where things sit on each axis. It's not a matter of opinion. Yeah, it actually should be verifiable. So if we look at this on on consensus, I get 3 categories. Down here, a very small group of people truly believe in something. Here it's orthodoxy. And then finally, everybody agrees. That's called synchrony. So everybody is synchronous, everybody is in agreement. On the evidence base, it goes from, it's self-evidently true, it's beyond reasonable doubt, we've got empirical evidence. Yeah, the Earth does go around the sun. It's a bit perverse to say it doesn't in these modern day and age. I've got evidence. Yeah? The second one is case-based. That's like Poppinerian for those of you into philosophy. I've got cases which show it works, but I can't say it's universal. I can do an experiment to refute it. The experiment fails, but that still doesn't mean it's true. All right, so case-based approaches and inductive logic really fits there. And finally, down here, it's gut feel. Yeah, it's abductive. It's the sort of stuff where you haven't got much evidence. Again, those axes are fairly easily understandable at all levels of management. And from that, we basically say what happens with new ideas is they come in the bottom left. They actually oscillate between consensus and evidence, but they should really stabilize. The grey line on the diagonal is called a line of coherence. So the argument is you need to stay on that line. If you move off the line, you end up in actually potentially a bad space, yeah? And you need to pull yourself back. Because if you get too much evidence without getting buy-in, or you get too much buy-in without getting evidence, those are bad places. You need to step up that line. That's a smooth transition. And of course, not to do it, gets some oddities. So down here, that's where a small group of people know they're right, but nobody else agrees with them. Now, everybody been in that position at some stage in their life? The normal strategy for people in this group is to tell everybody else why they're wrong and to try and explain to them time and time again why you're right. And then you wonder why you get taken out into the village square one lunchtime, tied to a wooden stave, faggots of wood get put around you and people arrive with torches and you get burnt alive, right? I mean, that actually happens metaphorically and it used to happen physically, right? That's actually quite a dangerous space because I've shifted off the line. I've allowed people to go down an evidence-based approach and become a small group without pulling the rest of the organization with me, which actually means I'm going to lose value. So there are 2 strategies to deal with that. One is coaching. Is giving them people who can interpret them to the wider community, who can actually explain to them how they have to lose some of their truth in order to go back a bit before they can go up, or can reinterpret them into the language of the orthodox group within the company. So coaching is one strategy to deal with mavericks. The other strategy is put them in a sandpit or create skunk works. If you've got the authority, you've got the budget, you hide it. More great creativity has been achieved in IT through skunk works than anything else. Yeah, but it's put in a small group of people who you think may be right in a safe space to give them a chance to get the sort of language which will convince a wider community. Yeah? On the other hand, you also may have this situation. This is, I'm afraid, far more frequent. Everybody has agreed, but there's no evidence for it. Like banks on prime lending, if you want a different case. Actually, when everybody falls into step, it's normally a sign of impending catastrophic failure in strategy and finance. Yeah? So that's where actually everybody says, no, we don't have to go and do research on this. We don't have to check it. We all know it's true. Don't argue with me. That's an early warning sign. Yeah? And the strategy on that is fundamentally, if it's over there, it's not too bad. Yeah? You kind of like, you've got some evidence for it, but you need to increase the level of challenge. On the other hand, if you've got to the top left, you've got to break it up. That's where good leaders actually break up teams. Bring in different people. Don't let people work with people anymore. Move them into different spaces. Bring in people from outside with radically new views. You don't know what the right answer is, but you know you've got to break up the consensus. You've got to reduce it down that vertical axis. Okay. Now that's a generic framework. Okay. Let me now apply it to IT. What actually happens with Scrum and Kanban is they assume they're up in that space. In order to start the process, to write the things on the card or to start a sprint, you assume there's some evidence and there's some buy-in to the fact this is a requirement. Right? Nothing wrong with that. And of course, when you operationalize it, it's moving over there. The trouble with all of this is it misses out that. And that's one of the most important stages. Because if you move too quickly into that middle space without going through the early space, you know, remember the concept of Schrodinger's kittens from yesterday, which I thought was lovely? Yeah, some kittens may survive, but you're going to kill some which actually you should keep going. Yeah, moving into that is, in complexity terms, it's called premature convergence. It's moving too quickly to a solution without exploring the options. So what I want to argue is that there are two strategies which need to come before you move into the current formal Scrum process in this space that you need to do around user requirements and also around understanding technology capabilities. The first is what I call safe-to-fail experiments. Again, one of those spiders of the coherence argument. Now, the point about this is not to say, let's test an idea out several times till we get it right, because that won't explore a wide scanning range. What you do is anybody, whether they're users or IT or combinations of them, who have a coherent idea about something which might work, get a small amount of money to build a prototype or do something similar. But you manage those in parallel, not in serial, and you manage them as a portfolio. So there are basic rules for the portfolio. First of all of the elements must be coherent. There's a technique we use a lot called ritual descent, which is much copied in the community. That is actually a very simple way of doing it. Ideas are challenged by groups. They have to be safe to fail. And also they need to be small, discrete, what I call finely grained, tangible, practical, physical. You don't do big things in a safe to fail environment, you do small things. And so that's the basic set of rules for everything. Then you have rules for the portfolio. The first is that actually some of these things must be oblique. That means they mustn't be trying to solve the problem itself, they must be trying to solve a different problem. There's a book by a British economist actually called Obliquity, which shows that actually the vast majority of human change has been achieved not by trying to solve the real problem, but by solving problems near to it. That's Exaptation again. So some of the experiments must be in related fields, not trying to deal with the thing direct. Because what you're trying to do here is increase the scanning range. Right? So obliquity, at least one of the things must be oblique. Some of them must be naive. Now, naive doesn't mean stupid. In my time, I've put in biology professors into engineering departments because biology professors are naive about engineering but have deep expertise in a different field. I remember using the Lutheran liturgical design specialists to deal with knowledge management and the transfer of knowledge between nurses and doctors in an operating theatre. The reason I did that is I reckon liturgical design was about compressing complex ideas into a memorable form, so I thought he'd have some new ways of doing it. You see the principle? Joe Jenner and I sent a whole body of anthropologists to study holiday inns worldwide. We didn't use anthropologists who thought about industry, we used anthropologists who'd just come from the jungles of Papua New Guinea, and the stuff they did on mating rituals was actually quite fascinating. Yeah? But fundamentally, they looked at the Holiday Inn from a completely different, naive perspective. Right? So you introduce naivety and obliquity into your portfolio, and the final thing you need is effectively, you need contradiction. Yeah? Sorry. You need contradiction within the system. If one of the experiments succeed, at least one of the others must fail. If that's not the case, you're not spreading your scope wide enough. The number of possibilities is now too high for anybody to determine in advance what will work. Now, a neat thing about this is you're adopting a portfolio management, which means you can also adopt some high-risk, high-return experiments. I've lost count of the amount of IT people who want an excuse to go and do something really novel because they know it would work. But on its own, it won't stand a justification. But as part of a portfolio, it's easier to justify. You say, if it's down here, we haven't got this evidence, we've got these experiments, we've got these differences. at least some of our experiments will be high risk, high return. And most senior funding managers understand that because they understand portfolios. You're speaking the language they understand, and you're fitting in with those models. So kind of like stage 1, pre-traditional Scrum, is parallel safe-to-fail experiments following those rules. And you can actually download these from the website. This is the one we use for complicated actions. Actually, the real one is the complex one. So if you've got a complex experiment, what's the action description? Why is it coherent? What are the early signs of success? What are the early signs of failure? What's the amplification strategy if it succeeds? What's the dampening strategy if it fails? Is it oblique? Is it naive? So you actually, on your Kanban board, and I'm talking with some of the Kanban guys about this, you now have a new section of your Kanban for safe-to-fail experiments, and you have these forms up on it, and you check the portfolio across. And only those things then go into the more traditional Kanban and Scrum type environments. As I said, there's also action forms for complicated stuff where you can move straight into action. The other thing is kind of like another pre-process, and this is what I call enabling serendipity. Serendipity, I'm not sure whether it translates into Polish or not. It's an English word. It means a beneficial accident. It's another way of talking about exaptation. It comes from a famous story. Hugh Walpole picked up the word. The two princes of Serendip who were sent on quests, they never found what they were looking for, but they found more useful things instead. And from that we get the phrase serendipity. All right, now actually managing for serendipity is a key function of a modern IT department, because it's how you give competitive advantage to your organizational survival capability. So one of the key things, and this is kind of, I'm giving you an example on silos. Anybody got a problem with silos? People work in different groups and they don't talk with each other? Yeah. Stop trying to stop it. It won't change. The first known complaint about this is Sol on the Tyrant of Athens. So it's been going on for a long time. It ain't going to change, all right? And a key principle of complexity is very pragmatic. Systems thinking tends to define an ideal future state and close the gaps. Or says, you know, I need people who are like this and defines ideal qualities and tries to make people like that. Complexity says to hell with that. Change the system, people will change with it. Deal with people as they are now. Don't try and design a system based on how you would like them to be at some stage in the future. No? So silos are part of life. No? I'm going to use this as an actual case. Key to the thing we developed and partly patented is a concept called distributed ethnography. Ethnography is the process by which you go and observe people in work. You don't go and say, we've got to design a system to do X, what do you want in it? You go and observe them for 3 or 4 months and see what they do, and you build systems from that. That's reasonably well established in IT. It's underutilized because it actually doesn't scale, and you can only have a small number of ethnographers to observe a small number of people. The technique we developed, again, originally in counter-terrorism, is a concept that we call distributed ethnography, in which people become their own ethnographers, which means they self-interpret their own work experience and their own narratives. And that works fundamentally in a user environment, for example. Well, let me give you an example of a patient journey. I'll use a non-IT one. We've now got people using our software who will actually tell stories as they go through going to the doctor, being admitted to hospital, out into community care. They're continuously telling stories throughout that experience into an iOS device, but critically, they're self-interpreting their own story at the time they tell it into a quantitative framework. So the interpretation is not done by an ethnographer or an expert, and it's not done by a computer algorithm. The IT community overhypes its capacity to interpret big data with algorithms. Yeah, what we've actually found is that if you give people a chance to self-interpret their own story, they add meaning which isn't in the original story. So they add layers of meaning to it. They don't interpret the actual story. And that's called distributed ethnography. So what I can now do with the user community, instead of going out and sending systems analysts on a mission to get rid of systems analysts, or at least put them into the right boxes, instead of sending a systems analyst out to interview people to ask what they want or holding a workshop, give you some basic facts. If you conduct more than 2 interviews, your brain forms a subconscious hypothesis, and you only hear things that match that hypothesis in the interviews you conduct thereafter. In any workshop, the workshop is fundamentally biased by the facilitator within 15 minutes max. Now, so you can't rely on interviews and workshops to actually get the reality. What we do instead is take a sample of the population, or take the whole population, don't ask them about new systems, get them to tell stories and index their stories. Every time something frustrates them, every time they see something they'd like, every time they think, couldn't technology help me with this? Continuous feedback over the population. And because it's quantitative, because it's self-indexed, as clusters of stories start to coalesce, you design software for those clusters, or you move into the safe-to-fail experimentation. Not only that, by leaving the systems in place, you can monitor system impact. Because if your software development now works, it will change the stories in the way they're indexed. So I've now got a measurement system, it's called impact measurement, which will allow IT to experiment with new system development, because if they can prove they changed the user stories, they've validated their investment. And that's radical if you think about it. It moves us to much more finely grained, different ways of working. We're dealing with modularity. And the key thing here is the human metadata. Just to give another example, we did a project in Nairobi not so long ago. We got stories told by refugees in the refugee camp. We've done a lot of work in the development sector, indexed by people in that refugee camp. We then took the same stories and give them to development experts in Washington and asked them to index it the way they thought the people in Nairobi would have indexed them. There was a strong correlation in Nairobi and there was a strong correlation in Washington, but there was no correspondence between the two. Everybody in Washington thought the solution to the problem was clean water in, dirty water out. Everybody in Nairobi thought it was about rebuilding communities so they could look after themselves. And we've yet to find experts come up with the same as their subject in any development project or any IT project. You can do the same thing. Get user stories, get your systems analysts to index them, compare the way your systems analysts index them with the way the users index them. There will be zero correspondence, because they're overlaying their own opinion or their own view, so you're not getting that dense scanning at the front end. And so self-interpretation is key. So that allows us to do some more radical things. Not only can I get this body of pervasive micro-narratives from users, but I could also take all of the technologies I know and love, which nobody will take. I had this job my entire time as a programmer. You know, I had things I knew I could do for users, but the users weren't asking for them. Everybody know that one? Or there's some cool new technology which you found at a conference, but you're not going to get anybody to accept it. Right, those go into a new database, and you index them using the same index set that your users are indexing their material. The method we did in developed by that for the way is called deliberately ambiguated indexes. This is a picture from the iPad. Basically, we give people triangles with balanced items between the triangles. So you have to do trade-offs. It's not like a Likert scale. Anybody done an employee satisfaction survey? Yeah, and we used to get them in IBM, right? It's a bloody nightmare. So you get this survey and they say, do your managers consult you on a regular basis, yes or no? Or scale of 10, all right? That was the even worse one. I used to phone up HR, who I had a bad relationship with because of an experiment I did on their use of Myers-Briggs, which they never quite forgave me for. I proved astrology was a better predictor than Myers-Briggs, and they suppressed the paper. Either way, they don't understand irony in the States, right? But fundamentally, I phoned them up and said, look, how am I meant to answer this? I've got, which are my managers? And some of them do, and some of them don't, and some of them should, and some of them shouldn't. And they say, well, average your experience over the year. And I said, you guys don't understand research. When we do employee satisfaction, we say, tell us the story you'd tell your best friend if they were offered a job in your company. Yeah, that's actually really valuable data. Then in this story is the leadership. Where does it sit on a triangle? Between altruistic, assertive, analytical. All of which are equally positive. Because overall, as a company, I need to be balanced on that triangle. So that's called deliberately ambiguated index. You're dealing with ambiguous data. You can't disambiguate it. You have to hold things at a level of ambiguity. So this is the weak signal detection and everything else. And we've got other methods as well that we're building on that, but that's the human metadata. And what that allows you to do, so here I've got my user stories, here I've got my technologies. Now I could just actually build stuff from micronarrative. This is the next stage on. They're both indexed with a comparable indexing set. So what I do then is I match the databases together based on the indexing. These are lots of small fragmented technology capabilities, lots of small fragmented user stories. And I'll get clusters. This is actually from a real case. This is Philips in Eindhoven. We got 4 clusters, which are combinations of technologies and user requirements. And those then become new service offerings, new products. This is genuine co-evolution. and interacting things at a granular level so that new patterns form. We also, interestingly, got two other clusters. Down here, user stories that had no technologies, which kind of like indicates you're losing track of the users, and technologies which had no match with user stories, which kind of like indicates a false investment. Now, see, this is a bottom-up, but it's also a continuous scanning. You're continuously tagging technologies, users are continuously telling stories, so you've got an ability to measure in real time and see new patterns. So what I'm now doing down here, let's come on to it, is my first stage is portfolio-based parallelism, and my stage before that is self-interpreted micronarrative. So what that does is it gets that first stage right. So when things go into Scrum or into Kanban or any of those other methods, they've got the right level of granularity associated with them. And the final couple of points to finish with, this is Goodhart's law in economics. Anybody heard about this? Any statistical instrument used for policy loses all value. Stratton's variation of that is easier to understand. The minute a measure becomes a target, it ceases to be a measure. And if you really want the heavyweight one, this is from a famous paper, a survey of all known research on human motivation. Extrinsic rewards destroy intrinsic motivation. All the evidence says that, but management consultants, executives, have this passion for defining outcome. The biggest single difference between complexity thinking and systems thinking, and they are radically different, don't confuse the two, is systems thinkers define an ideal future state and try and close the gap. So they think they can define a future state by measuring it and say achieve it. Complexity thinkers describe the present and evolve forward. And that actually gives you more resilience, and that's where we get into narrative-based measures of impact. I can say that your job over the next year is to shift the stories of the users so that they're balanced over the whole of one of those triangles. The only way you can achieve that measure, which is quantitative, is by changing the stories that users tell about IT. You can't game surveys. Also, you've got the capacity to see change in real time. So you can go to your staff and say, I want more stories like this and fewer stories like that, which is the instruction they all understand. Whereas increased IT responsiveness to users is a platitude. More stories like this, fewer stories like that, enables action, and that's what fundamentally complexity is about. And it links with this final model called the see-attend-act model, which says, do I see the data? Do I pay attention to the data? Will I act on what I see and tend to? Those are three separate processes. Traditional decision theory assumes if you put the right information in front of the right people at the right time and they have the right competencies and the right training, they will make the right decisions. And 90% of agile training methods make that assumption. The reality is whether you see the data is questionable, whether you pay attention to it if you see on it is even more, and whether you act is another question altogether. So we need to design systems which keep those separate. The way you get people to see things, the way you get people to attend, the way you get to act are different. Interestingly, micro-based narrative backed up by numbers is very powerful. What we're finding is the ability to say we have a correlation of 5.6 between these factors, and these are the stories which explain it. It's far more persuasive than a simple correlation or a conclusion. Yeah, people understand stories because they're persuasive. They understand numbers because they're objective. Put the two together, it's powerful. So what I've tried to do is give a basic introduction to complexity, the Cynefin framework, and I focused on one very specific aspect of Cynefin, the complex domain model. As I say, there are others, we train on that stuff. The chaotic domain is actually particularly important. That's about crisis management, about actually radical innovation. Yeah, but fundamentally it's about recognizing that different systems require different ways of working, and those ways of working may contradict each other depending on which system you're in. So it's diversity, it's resilience, but fundamentally it's about increasing the level of real-time feedback between users and IT, decreasing the granularity of requirements and technology so that things can interact and interoperate faster, and enabling the radical innovation of business purpose that can be achieved by exaptation and recognizing coherence. Thank you very much for your time.